Hello, hello. Again, one more time, welcome to all. Welcome back to the world of science. Okay, this is the 6th or 7th or 8th, I don't know which session of passion towards science, and we are sticking together for the end part of the first chapter of science from chemistry part, chemical reactions and equations. Okay, in the last class we studied about different types of chemical equations. Now, reactions among them. Which is your most favorite? There are 4 types you learn. Which is your most favorite type of reaction? Displacement or double displacement? Displacement, okay, because you are strong, you can kick somebody, isn't it? Okay, it's like the usage is another word, but in this, what do you say, for it won't meet our ethics. Okay, we are teachers, that's why I'm not telling that particular word. Okay, kicking somebody's. Okay, that's it. So in this last part, we can just make a quick revision about that 4 different types of reaction. It was about first one, combination reaction. 2 reactants combines together to form one product. Second one, decomposition reaction, in which one single product is decomposed into different compounds or products. Third one, displacement reaction. Activity, reactivity series. If you are strong, you can kick out somebody else. Understand? So, highly reactive metals will displace no reactive metals from its compounds. That types of reaction is called as displacement reaction. Double displacement. What is happening? They are switching their places. Understand? If 2 solutions are mingled together, okay, if they are reacted together, what is happening? These metals, what they will do? They will switch their places. Understand? Double decomposition. This means the same double decomposition, double displacement reaction. Understand? They are switching their places. Okay. So that are the main thing about these 4 types or different types of equations. You must understand by seeing one equation. What is that? And one more thing is there. I think I forgot to tell that in the last class. In a single reaction, lots of types of reaction is also happening. And a reaction can be displacement reaction, at the same time double displacement reaction, at the same time combination reaction, at the same time oxidation reaction, at the same time reduction reaction, at the same time redox reaction also. Understand? So don't get confused. Confusing questions will come, 100% it will come. Okay? A same equation, same chemical reaction can be 3 or 4 types. So don't get that much confused. There is a lots of example given in textbook. You can solve that. And you must write all those things in CW. I will tell how to write and all. Okay, notes and all. Today I will post it. Already some notes yesterday already posted in that WhatsApp group. Just take that, download that, and as it is, you must write it in your CW. It's good to take a print of that, but so too many pages, I think. Too many pages, 120, 135 pages. Not that much good. Just write it in your notebook. That's enough. Okay. Anyway, taking print is not a good method. The best study material is that your handwritten notes. That's the best thing to use as a study material. Okay, so all these notes and everything, within 3 days you must finish everything regarding this chapter. After that, next session we will start with the first chapter of which one? Biology or physics? Which one you want? Physics or biology? Okay, according to the chronological order, it is biology. We can start with that life process chapter. And biology is very easy than the chemistry. Okay, actually this chemistry, most of these things we need to solve all those things in lab. Understand? Live experiments and all. But traditional education is very difficult. Traditional classes is very difficult during this corona time. So whenever this corona situation is finished, then I hope we can meet together. And we can do all these experiments in lab. It is very interesting. Understand? Very interesting. Very interesting, right? Very interesting. Okay, the last part is. Okay, we didn't discuss about oxidation, reduction, and redox reaction, isn't it? Okay, fine. Oxidation. Gaining oxygen, giving out hydrogen. Reduction. Gaining hydrogen, giving out oxygen. Opposite, just opposite to each other. Redox reaction, both oxidation and reduction is happening. Understand? Redox reaction means a reaction in which either hydrogen is gained or oxygen is gained, and also hydrogen is released or oxygen is released. Such equations or such reactions are called as redox reactions. So the last part of the chapter is the application level. It is about corrosion and rancidity. Okay, corrosion is very familiar for you. Isn't it? Corrosion is very familiar for you. Mostly corrosion happens to who? We. Are you corroded? Anyway, corrosion? No. Corrosion happens to metals. Okay, metals. Corrosion mostly occurring in metals. Best example is what? Corrosion of iron. And I think this is something new, isn't it? Heard about that rancidity before? Okay, I am also hearing that. Okay, what is rancidity? Some ditty, what? Who knows? So let us see what is rancidity. We already spoken about an example. Go to kitchen, not to eat. Okay, and now you are hungry, but I am also hungry. Okay, go to kitchen and take a small amount of oil in a cap, and I told you to keep it in somewhere else outside. Kept. If anybody done that, just go to home today evening, just take that cap and just smell. It will be a foul smell, very bad smell. And anyway, I'll give back that oil to your mother and okay, my experience with the oil is finished, you can use that for cooking. She will use that? No, he will slap you first. Anyway, that oil, when oil get exposed to air, what is happening? It will gain oxygen. Same oxidation reaction is happening there. Understand? The fats in this oil, it will gain oxygen and oxides of oxygen is formed. And that oxide will damage that oil. Understand? That oxides will damage that oil. That reaction process is known as rancidity. Corrosion, you already know. These metals, when it is exposed to atmosphere, it will react with oxygen in the presence of moisture and forms oxides of that metal like a thin coating. That is called as corrosion. The biggest example for corrosion is iron, and rancidity is forming oxides of oil. Oxides of oil. Is this a common example or not? For example, if you are making something with oil, some curry and all, that happens if you forget to keep that curry in the fridge during night time. The next day morning, Mommy, I am hungry, I need food. You are going to the kitchen and telling that. But mom told, I already told you to keep that curry in the fridge. Go and take that from the fridge. But you will tell, oh my God, mom, I forgot to keep that in fridge. What will happen to that particular curry? It will affect with rancidity. Understand? It will affect with rancidity. It will form an oxide with the fat in the oil, and it will damage that curry, damage that food. Understand? Anyway, even if you are hungry, don't avoid eating that. Okay? It will be a big problem for your stomach and all. So let's see what is corrosion. Simple. Forming of what? The process in which iron particles get coated with a reddish brown powder when exposed to moist air is known as corrosion. In the case of iron, moisture is important. Understand? Without moisture means presence of water in air. Okay? Presence of water in air molecules, that is very important, otherwise no corrosion will take place. Understand? If you are keeping iron in a dry place, there won't be any corrosion. So corrosion means the process in which iron particles get coated with that reddish brown coating. Have you seen that? I don't have anything which has corroded here, otherwise I will show you. Anyway, you already know about this corrosion, isn't it? Corrosion of iron. It will covered with that reddish brown particles. So that is called as corrosion. And what do you mean by rust? Rust. R-U-S-T, rust. The equation of rust is Fe2O3, isn't it? Fe2O3. It is ferric oxide. It is the ferric oxide of iron, rust. That brown powder is called as rust. Is it good or is it bad? It is bad. In the case of iron, it is very, very bad. You know, in fact, billions of tons of iron, billions of tons of iron is being wasted because of this rusting every year. Billions. Just imagine that quantity, isn't it? Actually, that iron, it is being disintegrated. It is going. Actually, it is dying out. Understand? If rusting continues for a long time, the entire iron will be changed into that oxide form, and there won't be any iron left. So, rusting is a bad thing. And in the case of other metal also, in the case of copper, in the case of aluminium, in the case of zinc, this corrosion happens common in most of the cases. When a metal is exposed to substances around it, such as moisture, acid, etc., for some time, a layer of hydrated oxide is formed. This process is called as corrosion. Understand? Not only water. If a metal is exposed to some acids, acid is highly reactive, isn't it? If you are exposing that metal to acid also, corrosion can occur. If you have lab means, if you put some piece of nail in concentrated sulfuric acid, what will happen? Lots of fumes will come, and that piece of nail will dissolve in that acid. Okay, that much high reactivity is there for those acids. Leave it, that's not our problem. Our problem is problems caused by corrosion. What are the disadvantages of corrosion? Understand? If there is no disadvantages for corrosion, no problem. No problem. Why painting all this iron? What all things we are making with iron? Why we are painting it? To stop corrosion. We are paying money to paint all those things. For what purpose? To avoid corrosion. Because corrosion is a problem. Understand? So, problems caused by corrosion. For example, it can damage the body of our car, bus, bike and all. Most of the automobiles are made by mostly iron, isn't it? So, when this iron will react with the moisture in the atmosphere, it will become rust. And continuously rust is forming means it will damage the body parts of our car, bus and all. Next one, it will damage metal bridges, iron rail lines and all. Have you seen bridges, big bridges? In big cities, if you see that most of the bridges, it is being made by iron, isn't it? Steel, mostly made by steel. It is fabricated, manufactured by steel. So what is happening when corrosion occurs after long time of exposure through air, these parts of bridge it will corrode, and when rust is formed means that much particle of iron is taken away from that, and when iron is taken away, the stability, the strength of that bridge will reduce, and there is a chance one day it will collapse down, it will break down. Okay, so that is also a big problem. In the case of rail lines also, iron bridges are not familiar for you, I know that, but rail lines are very much familiar for you. Have you seen train? Anybody did see in a train? Okay, fine, you all seen the train. So where does this train runs? Through air? No. Through road? No. Through water? No, I know you know that it's run through rail lines, isn't it? Railways are there, railways or railroads are there. So that railroads are also made up of iron. Understand? And mostly that it is not coated by any paint at all. So daily what is happening? It is corroding and it is changing its property from iron to rust. So it is also damages the railroads and all. Have you seen that it will damage us ships? Can you believe that? Oh my dear kids, this ship actually it is made of steel, iron and steel. You will ask me, if you are making ship with iron, will it float? It will go down with the water, isn't it? Now my dear kids, most of the ships it is being made by iron and steel. Okay, so some small boats and the yachts we are using in local areas, they are made up of wood, but mostly the entire ships, cruisers, speedboats and all are made by this iron and steel. Okay, there's a particular property called buoyancy, which makes them float over the water. Okay, and if you are making this ship with this steel, what will happen? Anyway, this ship is every time it is in water, direct contact of moisture, isn't it? So there is a chance of corrosion. So overexposure of this water will causes corrosion in that ship plates, and it can damage that ship also. So another question, mostly it's a 2 mark question, mostly repeated, very easy question, you already know the answer. Why do we apply paint on iron articles? What is the reason for that? We have an iron, what do you have? A hammer. Or, okay, these rails of our window. Understand? There is a lots of road in that window. Why we are painting it? Why? For looking it great? Painting will add beauty to that. Isn't that? No, because if you are painting, the paint will make a coat. Understand? It will coat the outer surface of that iron. So corrosion won't happen. Corrosion only happen when moisture reacts with iron surface. Understand? And if we are coating it, there won't be any space for the moisture to enter the surface of the iron. So it will avoid corrosion. To avoid corrosion, we are using paint. And another method of avoid corrosion is galvanizing. Understand? Galvanizing these metal parts. So nowadays when you are seeing, there's a lots of, if you go to a hardware store, you can see a lots of pipes, rats and all in those stores. If you are asking, they will ask, you want galvanized iron or common iron? What is this galvanized iron? Actually, galvanization means coating the surface of common iron with another types of metal. For example, zinc. Zinc will not corrode that much. Understand? Zinc will not corrode that much like iron. So we coat the iron surface with this zinc so that this moisture cannot affect the iron. Okay, galvanization and painting is also 2 different methods to stop corrosion. Next is what? Oxidation of fats and oils when exposed to air is known as rancidity. Oxidation of oil is called as rancidity. Rancidity is good. Rancidity is bad, you know. But if the temperature is high, then also there is high chance of rancidity. Understand? When the temperature is high. To avoid this rancidity, what we are doing? To avoid this rancidity, there is a special thing called antioxidants. Okay, antioxidants. I will give that definition also. Antioxidants we are using to avoid this rancidity. And you know this or not, while cooking, really you are using a lots of antioxidants so that that curry won't get bad. Understood? Just ask your mother, are you using antioxidants today for dinner? Morning time, I need this antioxidants for breakfast. Your mother will be wondering, oh my God, my student, what happened to that child? I think she has some mental disorders, isn't it? Just go and ask, mother, what antioxidants are using for today's cooking? Okay, just leave it my kids, just joking. What happens when food becomes rancid? What happens? You are very familiar with that, isn't it? Just, not even that food, I know you won't waste any food. You are the good student, you don't waste any food, you will completely finish that, what all things your mother is making at home, isn't it? Okay, fine. So I am just asking, what is just, some days you won't clean your plates. And in the morning time when you are wake up and you go and will just see. A simple example is your tiffin box. Am I right? Simple example. Mostly you are not clearing your tiffin box well from school. And just imagine that it's Dasara holiday. Today, the Dasara holiday is going to start and you are just at school and having your lunch and you are very happy, so you won't get enough time to finish that food. There is some balance of food, some waste of food is there, so just you close that tin. You close your lunch box and you keep it back in your bag, and after that, goodbye to all, you are going back for home for celebrating Dasara vacations. And in between you forgot to wash that tiffin box. And after 10 days holidays, Monday morning when the class is starting. Again, you just taken your bag, you checked your books and all, you found out your lunch box inside that bag. Take it, open it up and just smell how it is. How it will, how will it smell? Oh my god, no, it's a disgusting smell, isn't it? It will be a disgusting smell, my kid is get this. This is because of rancidity. Understand? That is because of rancidity. That food will make oxides. Understand? It will make oxides of oxygen and it will become very bad to taste and smell. So how to prevent this rancidity? How? For example, if something we are frying in oil, if it is exposed to air, it will get bad very fastly. So better to avoid overexposure of air. We can use airtight containers, isn't it? Mostly all those things what your mother is using for cooking, she is storing it in airtight containers, isn't it? So that this rancidity won't attack the food. Next one. Have you seen that pack of Lay's, Kurkure and all Cheetos? Have you seen that? They are filling a lots of air inside that, isn't it? For what purpose? So that while buying we will think that, oh my god, that the entire pack is full of potato chips, isn't it? No, it's not a business trick. Actually what they are doing, they are taking out the oxygen from that pack and they will fill inert gases into that, like nitrogen, neon, helium and all. They will fill inert gases inside that pack so that there is no even single trace of oxygen. And if there is no oxygen means rancidity won't happen, oxidation won't happen and that potato chips will be fresh for a long time. Understand? The common chips what we are making at home, it won't stay fresh like that packed chips because we are not covering it with any inert gas. In the case of that big companies like Lay's, Kurkure and all, they are packing it and inside that pack they are filling some inert gases so that the presence of oxygen is completely vanished. And by adding antioxidants also you can reduce this rancidity. For example, tomato is a good antioxidant. It will help the age of food more. Understand? If there is we are not adding tomato, this food will become bad very soon. Corn is an antioxidant. Carrots, orange, nuts, the peanuts, they are also antioxidants. So I think that's the end of it. Mostly all the portion in that chapter we covered. And one more thing, somebody asked me a doubt that why we are using that. 1 second, I will take one back. Why we are using this thing? See. One thing I forgot during that classes. See. Mg plus O2 is 2MgO. So in the bracket there is like this. Solid. Here gas. 2Mg plus O2 balance. Here solid. Here aroma heat. Whenever you are balancing an equation, you must take care of these things. Understand, my kids? So what is involving here? Heat is involving. You must write heat in that aroma. And Mg, magnesium, it's a ribbon. It's in the solid form. That's why we are writing this one in bracket as S stands for solid, G stands for gas, L stands for liquid, and AQ stands for aqueous solution. Aqueous solution means that if that particular solid particles are dissolved in water, it is called as aqueous solution. For example, sugar solution, water solution. No, water solution is not a solution. Salt solution. Sorry, my kids. So these are the things. I thought that when we are doing these things in class, it will be more interesting for you to understand that. Okay. If you are balancing the equation and the end you are writing means you must mention that it is a solid, it is a liquid, or it is a gas. Okay. So that's the end of this chapter. Hope you see soon with the next chapter from part 2 of biology. No, part 1 of biology, life process, I think, life process. And that's also a basic regarding this science, biology part. And after that we will go for electricity, first chapter of physics. That won't be that much simple for you, my kids. Electricity is not that much easy to you to get. It is a bit more higher than the 10th standard level. I think this chapter was very easy, chemical reactions and equations. Question 4 marks, total weightage of this chapter is 4. 4 marks question will come from this part, mostly balancing the equation. Otherwise there will be find out which type of reaction is going on. Mostly 2 types of questions will come, and there is a chance for 1 mark question also. Anyway, for this chapter I have no concern. You will score full marks from this chapter. It's a very easy chapter. And after this, finish that notes. Okay, that notebooks must be neat and clean. Understood? Especially regarding science and diagrams. And for this chapter, there is no diagrams. There won't be any diagrams coming for the examination. So these equations, then balancing the equation, just do it again and again. Otherwise, we will forget that method. If you know that method, it will be very easy for you to balancing those equations. And in the next class, we will see you with a new subject called biology, and I will give these notes and all. And Sunday you can sit and finish all these notes. Try to finish it before Monday, and make that notebook perfectly done before starting the next chapter. Understand? There is not that much difficult questions in this chapter. So I am Mr. Raj signing off from this part of the world. I hope you understand all these things in this chapter. If any doubts means, you can comment in that chat, and one special video I will make for solving all the doubts of all my students. Okay, so all the best for your preparation for the public examination, and enjoy your life. Okay, enjoy your life. Exam means a long way apart. Long way is there. So now what do you want to do? You enjoy your studies. Okay then, this is Raj signing off from this part of the world. See you soon. Stay at home, stay safe, be healthy, and Jai Hind.